Hi everyone. Welcome to this edition of the Bazel Hour. This is something that we in the Scalable Builds group at Tweag do every few months or so. We basically pick a Bazel related topic and explore and dig into it a bit for the length of the session. In previous sessions, we've looked at some of the rule sets that Tweag has created for Bazel. So I think last session we looked at rules Haskell. We've looked at rules Nix packages in the past as well. The theme for this session is a little bit different. We're going to be looking at querying and introspection more generally. And by introspection, I mean basically any way which you can you can get information out of Bazel about your build, maybe about its structure, dependencies, and so on. And I guess introspection isn't the first thing you sort of think of, perhaps, when you think of Bazel. Some of the top things that draw people to Bazel, I think, are its correctness and incrementality properties, maybe features like remote caching or remote execution. But it also has many powerful ways to query and get information about your build. And that's kind of fortunate, really, because given what a really complex tool Bazel is, you really need support from the build system to be able to answer some of the questions that come up as you're working. And that kind of goes double if you're working in a mono repo, because no one individual can hold all of that context in the head at once. So you want to be able to lean on your build system and be able to ask it questions. Just to give a quick concrete example of something you might, when you might want to run a query. Let's say you're working in a large mono repo and you're planning to change some library. You have a fair idea of what work is involved in changing the library itself. But then, of course, you're going to have to refactor all the downstream services and applications that depend on that. So in this case, you might run what Bazel calls a reverse dependency query, which is where you ask what other targets in this repo depend on this target that I'm about to change. And there's lots of other useful things you can do with queries. But just before we get started, I just wanted to give an overview of what I'm planning to talk about. I was thinking of spending the first 15 minutes or so sort of covering some of the queries you can do. Then I want to very briefly talk about Skyframe. It's a complicated topic, so I'm not going to say much there. But then I'm going to move on to talk about this new tool I've been working on, which lets you import Skyframe dumps from Bazel into Skyscope, and then you can explore the build graph interactively in your web browser. And this is what it looks like, just as a quick preview. So yeah, we should come on to this for the second half. But to begin with, let's take a look at some of the queries you can do with Bazel. So I'm going to be using protobuf for this example, and actually the Bazel repository a bit later as well. You've probably all seen, this is perhaps the most basic query you can do. This just lists all of the targets in the protobuf repository. By default, it outputs in what's known as label output format. If I say output help, help is not actually a valid output format, but it now tells me the other kind of output formats I can use. So yeah, this has just given us the labels. Perhaps a bit more useful is if you ask for label kind. Now it's telling me what kind of rules these labels are. So you can see these are CC libraries. We've got a general here, a PyTest, and some others. So I'm going to narrow this query a little bit. Instead of searching for across the entire repository, I'm going to use the all wildcard to search for stuff in the root package. You could use this like if you had a package called package name. This would give you all of the rule targets within package name. But because it's empty, that's just the root. So we have a few here. I think it's under 100 now. Yeah, so compared to the 1700 we had before. You can see we've got quite a few aliases. There's some CC proto library, a CC binary. So let's take a look at some of the functions you can. So far, we've just been doing target sets. You can also use various query functions. So the first one we'll look at is the kind function. This takes two arguments. The first one is a pattern to map. It's a kind pattern, and the second is a set of targets. So if you give something, so the first arg is matched against the kind that label kind prints out. So if I do this now, you can see it's just returned me all the alias rules in the root of the repository. There's quite a few of those, so let's look at CC binary instead. So yeah, now we're seeing just two, the proto-C target and the proto-C static target. Moving on to look at another kind of output format. Next up is build. So this is perhaps the most, if you had only one output format, it'd probably be build. That's probably the most useful. And what it gives you is something that looks quite like what you'll see in the build files you write. It's not exactly the same, and we'll dig into that in a second. So if I look at this is just the build file in the root of the repository. So let's take a look at that. And it says that this target comes from line 225. So yeah, we see on line 225 there's a CC binary. Its name is proto-C. It has some COPS. This looks a bit different. COPS here and linkops have this select, but and over here they have these variable names. But if we just trace back where this comes from, it's in build defs CPP ops. So let's look at that. That's our build defs CPP ops. And now we see what's got going on. Here, these variables have been defined to be select statements. And over here, you'll see the selects directly in the output. It's kind of like, if you're familiar with C or C++, it's kind of like seeing what happens after the C preprocessor has run. So you won't see Bazel macros, for example, macros which generate rules. What you're seeing from this stage is what happens after Bazel's finished loading all the build files and evaluating these variables. Moving on, we've got a lot to cover, so let's look at some other ones. I don't really have time to go into min and max rank, but these are quite useful for finding out how far down the dependency graph things are. So min rank will tell you the minimum number of nodes you need to follow from a top level node to reach a particular target. And max is if you take the longest path that you could. Package and location aren't especially interesting. I mean, package just tells you which package a target is in, but you can basically see that anyway from its label. And location just tells you the build file, which we've already seen is this one. Graph is an interesting one. We should take a bit of time to look at that. If you do output graph, you get given a graph is graph specification. You can do graph output for any query you do, but it's most useful for particular kinds of queries, the sum path and the all path queries. Before I do that, actually, I should probably show you another query, which is filter. So filter will let it takes two arguments. You can specify a set of targets as the second. So I'm going to give all targets in the repo. And then you can say something like, I don't know, arena align. So this is something that I happen to know is a library in the protobuf repo. If I query for that, it's now found it for me. So now that I know some library that's somewhere in the repo, I can do a sum path query from the proto-C target that we've seen before. So the first argument is the source target, and the second is the destination. So now it shows us that proto-C depends on proto-C lib, which depends on code generator, and so on, down to this one. But there's actually a little more going on here. And if we look at the graph output, and then we pipe it through, so this gives us a definition like that, which doesn't make a lot of sense as text. But if we pass this through GraphViz, entry, we can see a visualization of this. And then interestingly, so it looks here like it might just be a linear, straight, just a single path. But we actually see, although that path does exist in here, there is also a direct dependency on arena align from proto-C lib as well. And then the other query function for which graph output works really well is all paths. So let's send this to graph 2. That's the web browser. So yeah, there's a lot more information here now. We've got Proto C right at the top still, and somewhere down the bottom is Arena Align. But instead of just having this fairly narrow, thin path down the middle, you've got all of the paths you could possibly take to reach it. And this is kind of understandable, but it's a bit of a mess. And this is something which Skyscope actually does a fair bit better. So I'll show you how you can do that a bit later. There's a few more things I should say about query first. I've done the kind query. So the atta function is another very useful query function. This one takes 3 arguments. First one, actually maybe. So the first argument that you give to an atta query function is an attribute name. So attributes are things like name, visibility, tags, generator name, cops, anything that appears on the left-hand side of an equals here. So if you're familiar with the manual tag, so it's not on this particular one, but you can add a tag manual like this onto your targets or your tests, and then Bazel won't run those automatically when you do a wildcard query. You have to explicitly invoke them, and that can be quite useful to do if maybe one of your targets is not ready to pass CI yet. So let's have a look in the protobuf repo and see how many targets are tagged with manual. And I'm going to output this in builds format. But yeah, you can see now it's returned us this Objective-C alias, which has got manual, this protobuf obfusc manual, and so on. So there's a lot you can do with atta. The thing, this is a regular expression. So if you want, so it's actually found, it has an imaginary dot star at the beginning and at the end. If you wanted to find things that just had a single, it matches against the list format. So you'd probably do something like this. So I think that's probably enough for query. Let's move on to the Bazel C query now. So there are 3 main types of query. I perhaps should have said at the start, but there's query, C query, and A query. And they sort of correspond to the 3 phases of Bazel, the loading phase, the analysis phase, and the execution phase. So I'm going to go over to the Bazel repository itself now. So this is where you build Bazel from. Make sure that's built. The thing with C query is it only gives you information that is in your build graph already. So if I just do a Bazel shutdown and then a Bazel config, there's no build configurations. If I do a Bazel C query, there's no information yet. Actually, that's not quite what's gone wrong there. But basically, to get value out of C query, you need to do build some targets first. So I'm going to build Bazel bin and bin dev and this dist file thing. It shouldn't take very long because it's just checking the cached actions. And now when I run a Bazel config, I see that there's these 5 different configs have been populated into the graph. You can ask Bazel what one of them looks like. So I'll pick this one maybe. It's quite a lot of information. So nearly 400 lines. And yeah, it just contains all the kind of configuration about your builds, things like options for the C compiler and so forth. Perhaps more useful than just looking at the whole config is if you give it 2 different configs, it will give you a diff. So I'm picking 2 similar looking configs. They're both exec and optimized and stuff. So yeah, this has given us a diff now. It tells us the only difference between them. The left-hand one has remote JDK 21 and the right is JDK 11. So that's preliminary for C query because it works closely with config. So now let's have a look at an actual C query. If I look for Bazel bin and maybe Bazel bin dev, you might be tempted to, for Bazel build, you can path multiple targets. So you might be tempted to do something like this, but that's a syntax error. So Bazel query actually needs what are called query sets. And the way you compose query sets is with operators like union or intersection. And And these also have short versions, like plus is equivalent to union. So if I run that now, we're going to see something a bit different to what you would get if you did it with query. So if I just do a query, this is pre-configuration, so you just see the unconfigured targets. Running it with cquery, we now see that there's one Bazel bin dev configure target, but there's two Bazel bin configure targets, and it gives us the config hash as well. So you can actually see the difference between what these are. So yeah, it looks like there's some difference in C options. The one on the right is an execution configuration. So there'll be a configuration that runs on during the build, as opposed to the target configuration. So that's the basics of cquery. I actually need to find another target first to show you something else. So let's do a filter. There's a target called something like CPP clients in Bazel. Yeah, here it is. So this C++ binary is basically what you're running when you type Bazel, and the Java piece in the background is the Bazel server. But I wanted to find this to show you about about the RDEPs query function. So you might ask, so what RDEPs does, I mentioned it at the start. If you were changing a library and you wanted to find out what would be affected by that change, you give RDEPs two parameters. The second one is the thing that you're interested in finding the reverse dependencies for, and the first one is kind of the universe to search in. So it doesn't automatically search everything, because that could depend on external repositories and stuff. So what I can do here is say search all targets in the source, all rules within the source repository, and give me the ones which depend on CPP client. And I'm going to do outputs label kinds on this one. Yeah, so we see a bunch of different things here, some generals, generated files, and there's a mix of configs in here as well. So we might be able to clear up what's going on here a little bit with by looking at another function, the config function. And this is a function you can only pass to cquery. So this is not a function you can use with query, because query has no idea about configuration. And so I could say I'm interested, instead of all the configurations, there seems to be a slightly less than of these D ones. So what I'm saying here is I want all of the configure targets in the source package, which depend on this particular configuration of the CPP client. So if I run that, you can see we get a fair few less. So the Bazel bin of the same configuration depends on it, and these other ones also sharing the same configuration. Just out of interest, let's see what the other configuration looks like. So yeah, with this one, you see that there's a lot more. And actually, we've got an exe depending on it as well. I'm not familiar enough with the structure of the Bazel build graph to fully get the difference between these configurations, but this is basically how you sort of explore the configured target build graph. Yeah, just before we move on to aQuery, the last main sort of way of querying, I want to talk about a couple of other output formats. There's files, so these two you can do graph and build the same as you could with query. Stylarc and files are not output formats that query supports. If you do files, what have I done there? Oh, it's a query, that's why. Yeah, so if you do a C query with output files, it will, instead of listing the targets or the configured targets, it'll list the output files in Bazel outs that those targets would produce. So that can be quite useful sometimes. Stylarc, I've not actually had a chance to use myself, but it seems like a really cool feature. If you choose this output format, then you can pass a Stylarc, Stylarc file to the query, and Bazel will run the code in that. Will pass the targets through the code in that as a sort of post query filter. So you can actually it's quite powerful. You can do a lot of stuff with the targets you find. But yeah, in the interest of time, let's move on to aQuery. So just like cquery gives you the configured targets, aQuery is how you query about the build actions that those targets produce. So let's start with a simple one. If I do an A query on the Bazel bin target, it just gives us this single action. It says it's a general, it's for this target, which is what I asked for. And we see the command line that this general runs. It's sources, oh yeah, that's all generals have this. And it basically zips some stuff up and can concatenate it together. Let's look at the CPP client's target, because that has a lot more actions. So if I do an A query on that, yeah, you see we get multiple actions. I think there's perhaps about a dozen of them. They're things like CPP link, actually we didn't see CPP link here. Well, yeah, there's a CC strip and so forth. So yeah, this has given us all the actions associated with this target. Just one other thing to show you quickly. A query only supports a few functions. It supports outputs, inputs, and mnemonic, if I can spell that properly. And these basically just let you filter all the actions based on those things. So if I wanted to find all the actions which produced a manifest file, for example, I think I could do something like the first parameter is the pattern mapped in the file that you're interested in, and the second again is the set of targets. So interestingly, yeah, you do run into this sometimes, that certain parts of the build graph aren't valid, so you get this error. But there's a very useful keep going flag you can pass to queries, and then I'm also just going to throw away the error to dev null. So now, actually, I think I need a pattern here. I think that's what's going wrong. Let's do dot star manifest. Yeah, so now we've output all of the actions which produce manifest files. You can see that there's quite a few of them. So that kind of query can be quite useful if you've got a particular file but you don't know where it came from in the build. You can find out the action and the target that produced it, and ultimately the build file that created that target. So yeah, I think that's probably enough for querying. I do want to show you the Skyscope tool I've been working on. I should say a few words briefly about Skyframe. It's the parallel evaluation and incrementality model of Bazel. We don't really have time to talk about that, and to be honest, you don't really need to know much about Skyframe or even anything, to be honest, to use Bazel day to day. But I do think it's useful to have some idea of how it works, because it gives you a better intuition for what Bazel is doing under the hood. And another reason is that the three different query commands that we've just seen, they're really just high-level interfaces over the Skyframe data structure. So whenever you run one of these query commands, Bazel is just reaching down into its Skyframe build graph to find and return the information that you want. So I guess the only thing I'll say about Skyframe is that you can get access to it from Bazel by doing a Bazel dump Skyframe command like this. This produces a lot of data. Even for a small repository like Protobuf, I think there's a few 100,000 lines. It's still counting them all. Yeah, I'm actually just going to interrupt that. I'm not sure it's taking so long. And as you say, as it says here, you shouldn't really rely on this information, because the developers reserve the right to change the format. All of the information of the graph is in here, but it's just quite hard to understand. So this is where Skyscope comes in. Instead of trying to look at that textual output, you can import it into Skyscope and visualize it there. So I'm just rebuilding to make sure the build graph is fresh. And then you can do a Skyscope import like this. Usually you pass a few more arguments to this. I'll show you that in a second, but in its most basic use, you just do a Skyscope import. The first thing it does is import all of these different configurations, and then it proceeds to do a Bazel dump, like I just did to less, and parse all of that. And when it's finished, you get a link that you can open like this. And yeah, here it is. To begin with, there's no nodes visible. Skyscope doesn't know what you're interested in yet, so it doesn't show anything. But you can click on this box and search through all of the nodes in the graph. You can search by, I'm going to search for the name of the top level target, but There's actually a lot more nodes than I was expecting on this. I think I've imported more than... Oh, I'm in Bazel, that's why. Sorry, let's go back to Protobuf a second. I was in the wrong repo. It works perfectly well on Bazel as well, but I was expecting to explore the Protobuf repo instead. So importing the configs again. I think there's about 100,000 edges, yeah. So yeah, this is the Bazel repo. This is the Protobuf repo. So you could search for Proto-C. You can use percent as a wildcard. So notice we've got a few different configurations here. I could start typing one of them, like 0E91, and it would start filtering it down like that. You can click on individual nodes here, and they'll become visible behind. This stays open so that you can continue making your selection and adding more if you like. Or you could just press enter at this point, and it will ask if you want to make everything you found visible. So yeah, this is already kind of interesting. We're seeing some structure here, but you'll notice that all of these action executions are identical, or at least nearly. If you open up the hover pop-ups and take a closer look, you'll see the action index is different. So Bazel knows these are different actions, but it's not very useful for humans. So what you can do is when you run a Skyscope import, you can pass a query expression, just like we've been doing. I think I forgot to show you the depths function, but it just gives you the transitive closure of all of the targets. And you can also pass an a query expression as well. And if I ran this right now, it would do a brand new import, but you can also give it an existing imports ID. And then it will import this extra context for actions and targets into this existing import. And this can be quite useful because in a large repository, you probably don't want to import all of the action context and the target context. It's better to start with a basic import and then iteratively add new context as you need it. But now if we refresh this, you'll see the action executions have changed from just action execution to actually having some nice mnemonics here. If we take a closer look, you can now see exactly what the CPP link action is doing. And also for the CC binary, previously that was just configure target. Now it's giving you the same output that you'd get from Bazel query with the build output. Sorry, so yeah, I guess I should show you how to sort of navigate in Skyscope. So it has a couple of, it has this concept of collapsed and expanded nodes. So when the node is surrounded by this gray outline, that means it's expanded. And expanded nodes have all of their edges shown, even edges going to other currently hidden nodes. The hidden nodes in this case are these little circles. You can click on these and it will make them visible in the collapsed state. You can then click on that and it will become expanded. And so you can sort of just click around and expand nodes. You can collapse them again. The main reason why I have this sort of collapse concept is because some nodes have a lot of edges, and very quickly the graph becomes, well, yeah, this one has a lot indeed. So this is all just different ways of sort of managing the complexity of the graph, trying to keep just the nodes that you're interested in visible at any one time. As well as toggling expansion and collapsing and showing new nodes. You can also hide nodes if you click Control. Let's see, I'm holding Control at the moment, and click a node. It'll hide it again. So that sort of reduces the complexity of the graph a bit. Let's just get a few more open. There's another thing you can do, which is hold down Shift and then make a selection of nodes. And when I release Shift, it's going to remove all the nodes I've not selected. So that just cuts you down maybe just to one or whatever. So these are all just different ways to sort of explore and kind of look at what you're most interested in about the graph. Yeah, I guess I should say that there's browser history as well. So everything that I've just done has been properly recorded in the browser history. So if you end up accidentally deleting a node that you were still interested in, you can always go back. You can go forwards as well and undo all of that. And actually, if you close the tab even and come back to it later, the state is saved in your local browser state, so you can always resume where you're at once you restart or something. Another feature is you can save the graph as you get it at any point, and this will produce a static SVG version of the graph. This one looks like a bit of a mess, but maybe if we, I think it looked nice at the start when I had just the proto targets. Yeah, if so you can sort of get the graph into a state that's interesting, and then generate a static image, and then maybe share this because it shows something that you're interested in. So yeah, I'll just show you a few more advanced features then. So actually, no, let's have just the proto-C CC binary. And if you remember before, there was this arena align library, and we saw that we could use some path to find a path from proto-C down to that. So if I look for arena align, I think it would, and I actually want the CC library. So using percent as a wildcard here. I'm not entirely sure which of this one, so I'm just going to add all 4 of these. So yeah, it was actually this one down here, and we've got these other ones as well. The reason these showed up in the search is because if we take a closer look at the build output, we'll see that the arena align library is a dependency. And when you do a search like this, it's actually searching through all of the context that it has. So it's also found these nodes while searching for protobuf arena align. But the feature I wanted to show you was, now that we've added this on, Skyscope has automatically discovered that there is a path from proto-C down to this. And if you click on this, it will open it up and show you, I say the path, there's actually multiple paths down, as we saw before in this all paths query. And Skyscope has just chosen one arbitrary one, but it's quite useful still to see how 2 things are connected. So one kind of use case, you often just add 2 nodes in and see, is there a dependency here? Another useful feature is if you've got a expanded node like this one and you double click on it, Skyscope enters what I'm calling the sort of neighbor search mode. And you can see it's in this mode by the flashing node that you clicked on. If you just click off, it takes you back, it undoes that. But going back to this mode, well, maybe it's not so obvious, but it focuses the input onto the search box. So what's happening here is Skyscope is doing a breadth first search out from the node that you've just double clicked on. And it stops at 16 because it could, there's, I think, like 30,000 nodes. It could find a lot, but I think 16 is a good amount to get an idea of the neighborhood around the node. And if you type something in here, it will start filtering dynamically based on your search. So if I start typing act, actions have the word act in them. Artifacts have the words act in them. So you can see it's already filtering it down. If I go all the way to act and execution, it's found just the action executions around this. And you can press enter to commit that and add those to the graph. If we take another look again at the neighborhood around this one and search for something a bit different this time, you could search for toolchain, and now you're finding nodes around here which are kind of related to toolchain configuration and stuff. Maybe config settings. So these are some config settings that this binary depends on, or perhaps we want to see the CC libraries that it depends on. So these aren't all the CC libraries in protobuf, but these are the nearest 16 CC libraries in the neighborhood around proto-C. So just pressing enter to commit that and make those visible as well. And so you can kind of think of the neighborhood search as kind of complementary to the finding paths between things. I like to think of the open path feature as sort of like a long distance depth first search. I mean, actually in this case there is a closer dependency, but that allows you to search across the graph, and then the neighborhoods thing allows you to sort of find some context around one or more nodes. Yeah, I guess you've seen me do this pop-up pinning thing. You can, even if you don't do that, you can double click on here and just copy that out. That might be useful. Or you can click on the label if you just want that. Something we haven't seen is build configurations in this. So if I add all those in, let's go on here. So if you hover over these, you get the same output that you saw from doing Bazel config. And we could also have a look at another one, but it's quite hard to see what's going on. If you pin another build configuration at the same time, Skyscope automatically diffs them. So we can see these configs are quite different. The one on the left has a lot of stuff, the one on the right doesn't. Maybe if I pick two closer configs, perhaps that one and this one. So yeah, these configs are much closer. The one on the left is an optimized compilation. The one on the right is fast. But yeah, this basically gives you, there's a few issues actually that I need to fix, but this gives you pretty much what you'd see in the command line if you ran the Bazel config. And actually, if you want to see what Bazel says itself, you can click on the label here and copy that. And then when you run that in the command line, it gives you, it's a slightly different layout, but it's basically giving you what you just saw in Skyscope. So yeah, that's basically all the features. We don't have a lot of time left, so maybe I'll just quickly show you another, show you what it running on Bazel. So yeah, here's a previous import I did of the Bazel repo itself. So maybe you could search for Bazel bin, please. And there's lots of different kinds of nodes. You can even see a sampling here by searching. Interestingly, it has environment variables are represented. So if you're not using strict action env, you can put that on and see, okay, these actions depend on this. So you could say like, I've got some particular environment variable that seems to be affecting my build. So you can find it in here and make it visible and get an idea of how the build depends on it. So this one, we can see the term variable is not used by anything, at least nothing that's currently visible. But overall, over here, the CC, the Bazel, LLVM, and libtool ones, these all seem to be affecting the graph in some way. And if we open it up, we can see, yeah, exactly how. So yeah, I guess I could go on for a while with this, but we don't really have much time left. So I'm going to stop there and just ask if yeah, if anyone has any questions or yeah. I guess I'd just say for sort of next steps. I mean, I think it's getting pretty close to be a useful tool now. I'm not entirely sure it is yet, but it seems to be like getting close. I think the next things I want to work on with this are probably performance improvements. It does actually work on fairly large repositories already. The largest I've tried it on had 3 million nodes and 37 million edges, but it really did struggle with that. It was taking about 30 seconds for each. If you look at the network requests as I'm typing here, it's doing a bunch of filter requests to dynamically update. Each one of these takes about 30 seconds on that huge repository. So I've got a few indexing problems in my database I need to figure out. But I think that can be improved. And I think that's important because I think this tool will be most useful on really large repositories. It's interesting to see it on protobuf, but you probably don't really need it to understand protobuf. It's a very small repo. Whereas if you've got hundreds of build configurations, I think a tool like this to be able to visually see the build graph could be really helpful. So yeah, I think I'll stop there, but let me know if you've got any questions. I'm happy to answer. Maybe we could stop the recording at this point if people prefer to ask questions without